Hello class, welcome to Geometry Lesson 7-4, which is all about similarity in right triangles. By the end of this lesson, you should be able to use similarity and the geometric mean to solve problems involving right triangles. So if we start by looking at example 1, which is all about identifying similar triangles formed by an altitude. Remember, altitude's a vocab word from a few chapters ago, and an altitude is the perpendicular height within a triangle. So if you draw an altitude to the hypotenuse of the right triangle, you can create three right triangles. So the altitude in this drawing would be CD. See how by adding in that line, I've now made it so there's one triangle, there's two triangles because there's a little one, and then there's three because of the second portion that was formed by that line. Okay, now the cool thing about an altitude in a right triangle is that it divides it into, the three different triangles, but also these are all going to be similar. All of these triangles are naturally similar triangles because all right angles are congruent. So we have, the right angle in the big one, the right angle in the second biggest one, and the right angle in the smallest. And then this angle repeats in there. So triangle CDA, that little one, is congruent to ABC, the big entire triangle, by angle-angle similarity. And then our the medium triangle, CDB, is similar to the large triangle ABC by angle, because we have the right angle, and then angle, we have the angle B that is repeated on both of those triangles. So again, triangle CBD is similar to triangle ABC by angle-angle similarity. Okay, so again, drawing in that altitude creates some cool relationships. Now, Theorem 7-4 is the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. So basically what I just said on the last slide, this is the theorem for it. If you want to take a screenshot of it, that is a great choice. Highly recommend it. But go ahead and do that, and let's move on. All right, example 2. So with example 2, if we want to find missing lengths within right triangles. Okay, so we are given that triangle PQR, so that whole triangle, is similar to triangle QSR. So the big triangle is similar to this smaller triangle. And if we were to redraw it, so we have two separate triangles, this is what it would look like, right? We'd have QSR and we'd have PQR. I highly recommend when you are dealing with these problems, redraw them so you have two separate triangles, because once you do that, you guys tend to be a lot better at solving the problems. But if you look at it as one solid picture like you were started with, it's easy to mix up the corresponding sides. Okay, so QSR is similar to PQR. Segment QS would correspond to segment PQ. Remember, the order that they're listed is very important. So PQ comes first, QS comes first, they are corresponding. QR comes last, so SR comes last, both of those are corresponding, and so on that way. Now, if we were trying to solve this, we want to find QS. In order to find QS, I can set up a proportion. So I can set up this proportion, and I can say, okay, I'm solving for QS, so I can put QS over PQ. So QS is the side that I'm trying to find. That's what the directions are asking. And then PQ is the side on the other triangle that corresponds. So I can put those as a fraction. And the proportion there should be equal to the proportion of two other sides. So I know SR, since that's on the same triangle as QS, I'm going to put that on top. And then SR lines up with QR on the other triangle. So I would put SR over QR, and then I can start plugging in numbers. I can say QS, I still don't know, over, and then PQ is 20 equals SR, I can replace with a 9, and then QR I can replace with 15. So I have this set of fractions here, these proportions actually, and then once I solve, I can multiply 20 to the other side. So then I have QS equals 9/15 times 20. And if I multiply that out, I get 12. So QS equals 12. Now, the geometric mean is something that you're going to practice finding. It sounds a lot scarier than it is. This definition is the way the book is going to describe it to you. I actually like the way that the previous book that we use describe it better. So I'm going to give you both, okay? So the geometric mean is the number x such that a over x equals x over b, where a, b, and x are all positive numbers. And really, if we want to solve for x, because more often than not, I give you a and b, and I say, what is x? And so if you look at that, we would cross multiply. So x times x would give me x squared, and then that would equal ab. However, I don't like having squareds, so I would change that, and I would say x equals the square root of ab. And so that's what I had typed there. This is kind of the thing that I recommend you memorize. If I ask for the geometric mean, you're going to multiply your two sides, and you are going to take the square root of those. And also, I should probably say I'm recording this video at home. That means I'm trying to use my trackpad to write and draw, so I'm sorry that it's not as neat as normal. But this saves me a little bit of time and having to wake up early. Okay, example 3, relating the altitude and geometric mean. So we just found out how to find the geometric mean. And that geometric mean, the way that you can find it is by setting up those proportions, kind of like what we did on the last example. So if we know we have triangle ACB and we want to find CD, the way that we find CD is we do that geometric mean. So in order to find the altitude, what you can do is you can say x equals the square root of 6.4 times 3.6. And if you do the square root of 6.4 times 3.6, you would get 4.8 as an answer. And that is what CD, ooh, that was a terrible C, equals. However, so that's how I would do it, but I do want to show you what the book would say. So the book would say to set up a proportion, which would look something like this. So the book would have you start by writing the proportion of the corresponding side. So you'd say AD over CD. So AD over CD would equal CD over BD. And then once you plug in those numbers, you'd have 6.4 over CD equals CD over 3.6. Then you would cross multiply, so you'd have CD squared equals, and then you'd have 6.4 times 3.6, which is 23.04. And then you would take the square root of that answer to get 4.8. So if you want to practice doing that, you certainly can. But if you're able to memorize that the median the altitude. The altitude equals the square root of the longer side times the shorter side on the hypotenuse. That is kind of a faster way to do it. All right, so why don't you go ahead and try to find CD? Good luck. All right, hopefully for your answer, you said CD equals the square root of 5 times 15. 5 times 15 is 75. And then I want you to, instead of giving me a decimal answer, I want you to start practicing simplifying your radicals again. And the reason being, chapter 8, I'm going to make you simplify radicals a lot. So let's get used to that again. So that 75, I can split up into a perfect square, which is 25, times another number. So 25 times 3 is another way to say 75. And then the square root of 25 is a 5, so that takes it out of the square root. And then the square root of 3 is a decimal, so we leave that inside the square root. And our answer is 5 square root of 3. All right, now let's look at the first corollary to Theorem 7.4. Remember, corollaries are just kind of another way of stating it's related to that theorem, okay? So we know that the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. So basically, that is the official math terminology for saying if you take this large triangle ABC, and you see how we have AD and DB make up the hypotenuse in the big triangle. If you multiply those two numbers together and take the square root, you get the altitude. That's all that is saying. The shorter side times the longer side and square root it gives you the altitude. All right, so example 4, relate side lengths and geometric mean. So we are given triangle RST, so that's our big triangle, and we want to find RT. So this is a little different because previously we were finding UT only, right? We were finding the altitude. But what we can do is still kind of set up that proportion. And so using that theorem 7.4 from earlier in this video, we can say that those triangles, RST, so the big triangle, would be similar to triangle RTU. So I'm going to outline RTU in green just to help us visualize, and that is similar to the big triangle. So I can set up a proportion. I can say RS, so the big hypotenuse of the entire triangle would be related to the hypotenuse on our smaller triangle that we're looking at. So RS over RT, and then I'd say equals RT over RU. So RT over RU. Then I can plug in my numbers, so 15 and 9.6, and I don't know what RT is. That is what I'm solving for. So I can say 15 times 9.6 is 144, and if I take the square root of that, I get 12. So the length of RT is 12. So why don't you try to solve these problems? So I want you to figure out what does JL equal and what does KL equal. Good luck. All right, so for this example, or this question, hopefully for JL, you ended up at 4 square root of 6, which is the same as approximately 9.8. And then hopefully for KL, you ended up with 4 square root of 30, or approximately 21.9. So the way that I got those was for JL, I split it up into two triangles, JLM and JKL. And I labeled, I knew that JM was 4, JK, if I did that whole distance, it was 4 plus 20, or 24. And then I could set it up as a ratio of JM over JL equals JL, so that's the repeated side among these two triangles, over JK. And so if I solved by plugging in 4 and 24, I got JL equals the square root of 4 times 24, which is 96, which can be broken up into 16 and 6, which is how you get 4 square root of 6. Then to solve for KL, I split it up into two triangles, KLM and JKL, or KJL. And then the side that's repeated between those two are KL, so I put those on my diagonals. And then I knew I had KM, which is 20, and I had JK, which was 24. And if I cross multiply, 20 times 24 is 480. So KL equals the square root of 480, which can split up into 16 and 30, or 4 square root of 30. I know those are kind of tricky, so if you tried them, awesome. If you tried them and get them wrong, still awesome for trying. If you just gave up because you were totally lost, make sure you ask questions. All right, so here is the corollary to number 2 to theorem 7.4. So just remember the altitude to the hypotenuse, so that CD line, divides the hypotenuse so that the length of the given leg is the geometric mean of the length of the hypotenuse and the length of the segment of the hypotenuse that is adjacent to the leg. So AB, that hypotenuse, over that leg would be equal to that leg over that median. So basically what we did on the last question, this is the corollary stating how to set up those ratios every single time. The key thing to remember is the repeated side is always diagonal to each other, or to itself. Okay, so then what if we want the value of x? So if we look here at this triangle, I know that my hypotenuse is made up of x plus 5 and x. So if I take my long leg, so meaning this long leg right here, that's x plus 5, and I put it over the short leg of that smaller triangle, which is 6, that would be the same as having 6 over, so we're taking that same side, that long leg of this smaller triangle, and putting it over the short leg, which is x. So then you can cross multiply and divide. This is where things really get back into the land of algebra, because then if I cross multiply, I have x times x plus 5, and if I distribute that, I have x squared plus 5x, and then I can subtract that 36 over. So I have x squared plus 5x minus 36 equals 0. And if you remember how to factor, you would look and say what two numbers add up to 5 and multiply to negative 36. So add to 5, multiply to negative 36, that would be positive 9 and negative 4. So you'd say x plus 9, the quantity of x plus 9 times the quantity of x minus 4 equals 0. And then remember, when you solve that, you would say x plus 9 equals 0. So if I wanted to solve for x, I would have x equals negative 9. Some people always forget that going from here to here, you have to change the signs. So then x minus 4 would really become x equals a positive 4, because you're going to add 4 to both sides, so you have x equals 4. And then, since we're talking about length and a distance, we need to only ever use positive numbers because length can't be negative. Okay, so I know that's kind of a lot as far as remembering algebra. So if you have questions, please don't hesitate to ask. All right, and then why don't you go ahead and try to also figure out the value of y. Good luck. All right, and then hopefully for this problem, when you were solving for the value of y, you were able to split up the triangles, and you said, okay, I have that smaller triangle, I have 6, and then x we already said was 4, so this is 4, and then y. And then you were able to look at the entire triangle, and we have z, y, and then if I plug 4 in, x plus 5, so 4 plus 5 plus 4 is 13. So this whole length is 13. So I can set up a triangle like this. And if I look, I can say 4 and y line up together, so I can say 4 over y equals, and then I have y and 13 line up together. So I can set up my proportion like this, cross multiply, so I have y times y is y squared, 4 times 13 is 52, If I take the square root of both sides, y equals the square root of 52. If I then want to simplify that square root, I know 4 times 13 is 52. So I have square root of 4 times the square root of 13. The square root of 4 becomes just a 2. And then the square root of 13, we can't simplify anymore. So our answer is y equals 2 times the square root of 13, which is approximately 7.2 if you aren't quite comfortable with simplifying the radical yet. And then here is the concept summary for this section. Really, the key takeaway is remember that when you're setting up your proportions, the sides that appear on both triangles always are diagonal from each other. And that should really help you with setting it up, and I highly, highly, highly recommend drawing yourself pictures and breaking up the triangles. If you have any questions at all, please don't hesitate to ask, and I'm more than happy to assist you. Have a great day.